So now this is a session that actually touches us all very personally, though perhaps we may not realize it. It's because of these devices that we all carry and use and which we cannot live without. You know, washing machines, TVs, everything. When they stop working, end of life, that's e-waste. So a lot of people actually don't know what to do with e-waste. That's probably the biggest problem, not just in India, but world over. Just to give you one small factoid, probably. Sometime in 2019, I think just about 17% of the e-waste in the world was believed to be recorded. And even that was worth about $10 billion. So there's a lot of wealth there, but we just don't know how to crack it. And probably that's what we're talking about this session. I've got my speakers here, and I'll start with Vikram, who's from Recycle. They're a marketplace. They connect generators of e-waste with recyclers and refurbishers. Okay, tell me, Vikram, give us an idea as to what Recycle is doing. First, the problem that you're trying to solve, and how are you going about it?
So, Recycle is a tech startup. We are building solutions for digitizing the waste flows across the product life cycle, starting from production, distribution, consumption, and disposal. So what you talked about marketplace is a disposal problem in terms of when material is being sold. Then where exactly should it go is what marketplace does in connecting the waste aggregators with recyclers across the country. But when it comes to actually waste flows, the problem starts right at the production level in terms of any electronics which we use or any production that happens, there is a large scale waste which gets generated. And traditionally what happens is the books of accounts, the traditional digitization that has happened, only values like whatever is a raw material, like finished goods, products which go into inventory. Whatever is waste is never going into the books. So it is never digitized once it becomes waste.
I think what what he says is, for some product to reach you, there's a fantastic supply chain. From how a raw material is mined or produced, the factories that it goes through, the warehouses, the retail shops, and finally you buy it off the shelf. But then when something is leaving you, to go back into that chain, that nothing exists. There is no reverse supply chain, right?
Yeah, exactly.
So what are you doing about it?
So the reverse supply chains need to be built.
Need to be built?
Yeah. Today we are, as a humanity, consuming about 100 billion tons of materials every year.
Okay. And listen to this, 100
billion.
100 billion tons.
Tons of material is extracted, is used every year, out of which about 8% is recycled material, remaining 92% is extracted out of Earth's core.
Wow.
So, and that, like actually, the example which I was giving you about gold, right? If you continue using the gold at the current pace, 17 years, we are out of gold from the Earth's core.
Okay, so here's the other number. There are 52,000 tons of gold resources in the earth. And if we mine at the rate of about 3,000 tons a year, we will have gold reserves to last us 17 years. But from 1 million mobile phones, you can get about 24 kilograms of gold. From 1 million mobile phones, you can get 24 grams of gold. 24 kilos of gold. The Hatti Gold Mines Company, which is the only primary producer of gold in India, it's in Karnataka, by the way, I think they extract about 6 grams from 1 ton of rock. So it's clearly, it's something big.
And you just put the perspective of mobile phones. We are a billion mobile phones country, right? Like in the sense, we're using so many smartphones as such, per se. And if you're looking at the life cycle of mobile phone, about 3 years, so you're talking about billion phones coming into the market, becoming e-waste. I mean, in a few years, kind of, and there's so much, material to be mined from there. Gold is the smallest amount of material because it's about 20 milligrams in a phone.
Yes.
But when it comes to other materials, other metals, copper, like silver and everything else, it's much higher.
Right. Okay. I'll just go over to Pavandeep of Atero. Atero, which has a plant in Roorkee, they extract about 22 metals with about 99% purity.
Yeah, 99 plus purity.
So how do you go about it? Could you give us a layer of the land as to how, how recycling takes place, and what are the new technologies that have come in to help you do that?
Sure. So I'll just start with tagline. It's not waste until wasted. I think so. This is the major aspect which we need to understand. Atero in Latin means waste. That is how the name has been derived, a waste recycling organization. We are the largest recycler of electronic waste in India and most advanced recycler of lithium ion batteries in the world. Why I'm bringing lithium ion batteries, your phone doesn't compromise of e-waste only. There's a battery which is a lithium ion battery which has critical metals. Critical metals like nickel, cobalt, manganese, lithium, graphite. We are the only company in the world which extract graphite and manganese out of lithium ion battery, that too of the category which can be utilized by the precursors in manufacturing new batteries, and we are supplying those out of the country. On the e-waste side, we are the largest producer with a capacity of 1,44,000 metric tons. The collection mechanism of our works with an experience of 15 years almost, and the plant was inaugurated by Dr. APJ Abdul Kalam, for which we are very proud. He studied our processes and then agreed to inaugurate our plant. That is the capability from where we come. We have 46 granted patents as on date on the global avenue, another 200 applied for. And we manage the most of the electronic waste in India. Last year, we have saved 1 lakh tons of carbon footprint by recycling electronic waste. We are the only recycling company in the world which has been approved by UNFCCC, which is the governing body for carbon credits. Plus, we have the ISO certification, which is 14064, where we are able to save GHG emissions by recycling these metals in environment-friendly manner. Just to give you an example, the lithium carbonate, what we generate through recycling lithium-ion batteries, it is 99% carbon neutral in comparison to the lithium carbonate which comes from Argentina and all those regions by mining process. If you will see lithium carbonate, it's a water guzzling process. You require 500k gallons of water to extract 1 ton of lithium carbonate. So that is the capability where we come from. We have other sources to help the consumers also. So CellSmart is one of the platform where as on date, everybody has multiple units of electronics which are sitting idle at their place. CellSmart gives you a benefit on the cash as well as OEM vouchers to exchange those products for a value term, which as an Indian, we only prefer. There is a value with any waste we want to sell. We are not keen to move ahead on those scenarios. So I would suggest these are the aspects which help on these scenarios.
Tell us, okay, lithium batteries that you mentioned. We are right now going through an electric vehicle transition, which means that all the lithium batteries that we're using now, we'll have to recycle them and again put them back into the industry. At what stage are things right now at? How big is lithium battery recycling in India right now?
See, on the number front, it's still on the development phase. The ecosystem is not to the extent which is there in China or the other aspects if I talk about the European countries.
Because industry is not, the electric vehicle industry is not that big right now, is that why?
See, in India we do not have the gigafactories which manufacture the cells. We have more of the assembliers, and most of the product comes from China, and subsequently we assemble it and produce a battery pack and move it into the market. Once the ecosystem is developed, if you talk about a gigafactory, at the initial phase of a gigafactory for 5 years, it generates production waste, which is critical metals, around 30% of its capacity.
All right.
And that is a major source of critical metals what you can get, and you can recycle and regenerate metals with a purity of 99% and above. If I just talk about lithium carbonate.
No, when you say this 99%, so what goes into it? What is the process like? I mean, people would probably love to know.
The process is a combination of what we have developed, the indigenous process, and for which we have the patents, is a combination of mechanical and hydrometallurgic process.
You're just melting them down.
So initially it has to be broken down. So a battery, if I talk about a mobile phone battery, it is broken down. There are two aspects. The metals are segregated, the casing, which comprise of aluminium or SS, and subsequently there is part of plastic in it. So there is anode and cathode inside a battery.
Yes.
A cathode is a combination of cobalt, lithium, nickel, whereas an anode is a combination of graphite basically. Yeah. And there is electrolyte inside the battery. So all this is broken down. The metal part and the plastic is segregated. Subsequently, we are left with a black powder, which is called as black mass in the lithium-ion battery industry. The black mass goes into the hydrometallurgic process, where subsequently, one by one, the extraction of different metals happen, starting with lithium carbonate, cobalt, nickel, manganese, and subsequently, at the end, the graphite is extracted. So this is the process what we implement, and in this, we are able to extract almost 98% and above of the metals from lithium-ion batteries.
Yeah, now, the black mass and the other minerals that he was talking about is what was mentioned in the union budget just last weekend, which means it's that important because everything we're going to be doing in the future will revolve around all these names, right?
100% correct. And in India, apart from Atero, what I feel, most of the players are mechanical recyclers. They only generate black mass and subsequently export out of the country. The export of this creates a lot of challenge. Please try and understand. Firstly, we are buying it from the international waters, importing, and subsequently after that we are exporting the critical metals out of the country. We are paying a higher value. Rather than extracting inside the country, we are able to generate these metals without mining. So it is called as urban mining. Yeah. What we are doing, through the urban mining, we get these metals in a much better proposition and of the same quality what we are mining. So we have been supplying these metals out of the country to the gigafactories, where they have made new cells out of these metals of ours, and they perform the same way as the mined material does.
Right, thanks. Okay, I'm going to bring in Ravi into this conversation. Ravi heads Pegasus, and so tell us about the recycling and the refurbishing. By the way, you don't have to recycle everything. If you have a laptop that probably that doesn't work, you could repair it. But if you have a laptop that is working and you don't want to use it, you're upgrading to something else, somebody else could use it, refurbished. Tell us about the things you're doing. And by the way, he's also working backwards, recycling things and selling them back to OEMs. Tell us about that venture. Who will use it as raw material for the new appliances they make, like washing machines?
Yeah. So at Pegasus, this is what we do. We don't try to recycle every end-of-life asset which comes to us. What we do is we do an asset verification test to determine whether it is an IT or home appliance, whether there is any life left in the asset which can be extended. So this is done by us in-house, and what is identified as refurbishable gets into the refurbishment factory, and we have different grades depending upon the age and aesthetics of the particular product. We either just functionally repair it and give it back to tier 2, tier 3 markets where they're not very particular about the looks and feel about the product. For the tier 1 markets, we even go up to the level of painting, packaging, and offering warranty to these products. So basically what we are trying to do is we are trying to extend the life of this particular appliances, which otherwise would just go into recycling and would cause a new product manufacturing for anybody who wants a new washing machine or a laptop. So that is with our refurbishment side of things. And what cannot be refurbished, that is beyond economic repair value, we also try to cannibalize, salvage the parts and offer it to the service markets, which offer services to all our homes where our appliances are out of warranty. They have a problem with it, and the repair person, rather than going and buying a new product, we have new part, so we supply back to them so that the life of the particular product is extended at the home itself before it comes to us. And what cannot be salvaged or refurbished gets into our recycling floor. And what we do is we not only do the deconstruction of these particular machines, we also move to the next level of pursuing the actual circular economy is by giving it back to the OEM who's manufacturing new product. So we are quite successful working with an Indian OEM who manufactures washing machines, refrigerators, ACs in the country. So what we do is we take the scrap aluminum and we make a ADC 12 grade and give it back to this OEM who manufactures new motors for their washing machines. And now they're even trying to create a new grade for themselves so that they can bring down the production costs in their refrigerators also. And also what we do is these plastics, the various plastics that come out of these various appliances, rather than giving it to the traders, what we do is we try to make a compounds and give it back to the OEM so that they can use this with the virgin plastics. And then when they're manufacturing the new product, they use the virgin plastics with the recycled plastics.
Yeah, the important thing that you mentioned was the part you do with actually cannibalizing end-of-life products, so that what you have, the appliances we have at home can live for a little longer.
Yeah.
All you need is that little part.
Yeah. So for example, if you have a washing machine, as you took already that example,
Yeah.
and if the PCB is malfunctioning in your home, so either you have a choice of buying a new PCB at about 8,000 rupees from a Samsung or LG.
Or a new washing machine.
Yeah. Or buy a new washing machine, right? So you don't want to spend 8,000 rupees for a PCB and don't know how long the particular machine works.
Exactly.
So that's where we come in. So because all of these things anyway has come to us as the end of life, and we have done the entire testing, and we are confident that this particular part has got life, and we give it back to the market so that this particular machine, which is to be repaired, are not thrown out.
Yeah, yeah. Now, Recycle has something interesting that Vikram was telling me about. So they've trained an LLM to actually know what, if you have a huge amount of waste that somebody wants to dispose of, what does it contain and what you could do with it. Could you just very briefly explain what you're doing?
Yeah, actually, so we built a product for industrial circularity. So which is, we found that the gap with the industries, enterprises, manufacturing companies out there is that the material, whatever, like waste, which comes as a byproduct, made from every production batch, that is like largely disposed out. And it is not like tracked in terms of where exactly it is going.
There's a whole lot of waste that's just...
Whole lot of waste coming from every batch, every main shift, which is like being disposed out.
Right.
There's no traceability for that. And we have built a product for that. Like, so in doing that, actually what we figured out is that when we're talking to industries also, a lot of times there is only so much time and knowledge in terms of what they can do with that waste. So think about an automobile company discarding off a radiator. They would not know in terms of actually that will eventually become a mixed metal scrap.
Right.
It is not actually sold as like bunch of radiators because there's so many parts which would be coming into a mix, right? So we have created, like we have trained a large language model to create a domain-specific model to find out in terms of, to create a reverse BOM out of it, reverse bill of material, to say in terms of what is the breakup of metals, material which is there as a part of this product. It can be...
What can you extract from that radiator?
What can be extracted
and what is AI in e-waste?
Yeah, so and what will be the value for it?
Oh, waste. Yeah.
So that's one thing. And if there are different recommendations, then in that case, actually, what are the processes that it needs to go through? Basically, what really happens is that once you've broken it down to a material level, it becomes a part of basic science. So, and that can be tapped into. There's a huge knowledge base which is out there to figure out in terms of what can be done with it.
To make it into raw material again.
Yeah, make it a raw material again.
Right.
Where exactly can it go? Especially in process industries, chemical industries, there's a huge opportunity out there.
All right. Okay. Now I'm going to ask each one of you, starting with Pavandeep. So, what's the biggest challenge in your sphere of work? You'll have to name one point.
See, this is a growing industry, and still there are a lot of compliances which is being promoted by the authorities into the picture. But if you'll foresee, we are moving into a scenario where the reverse logistics plays an important role. Reverse logistics is almost 8 times expensive than the forward logistics. So the challenge is the penetration or the collection of this material still is handled by the informal sector, and it moves into those scenarios. So I think so that is the biggest challenge which creates for us the availability of feedstock and the source from where it has to be collected.
Okay, for material to come into your recycling plant. What about you, Ravi?
Yeah, the biggest challenge, I think everybody will be saying the same thing, is the collection. It's just like, 85% of the electronic waste generated out of homes and the corporates lands up with the informal segment. And we as organized recyclers, we have to fight with the unorganized sector, which operates at a very, very bare minimal infrastructure on the costs. So majority of the times we find it very, very, very difficult to get the right materials to our facilities. So this is where we hope one day, some integration happens between the informal segment and the formal segment.
Right. And what would you say? I'm sorry, the question is for Vikram. What would you put at as the challenge that you face?
So the biggest challenge is it's a supply chain problem. Like we were talking about
the
earlier,
reverse supply chain.
Reverse supply chain in terms of the
how waste reaches industry.
Yeah, the industry has, spent the last few decades in optimizing on what needs to be produced, how it needs to be distributed, how exactly it needs to get to a consumer. So to the level of the latest innovations like quick commerce. But what really happens in terms of the post-consumption of the material is something which is not yet solved. So that is the biggest challenge. And it is not simple because the materials which we use is very different. The way we treat paper is very different from the way we treat plastics.
Yeah.
And the way a paper is kept stacked, plastic is thrown in dustbin, electronics are kept in a shelf, like portable electronics, right? So it is not disposed out because of a lot of actually awareness issues that it can be reused.
One of the things that we were talking about is the deposit refund mechanism. Right?
A deposit refund scheme
which is
system.
Which is exactly what we used in the old days. If you bought a Thumbs Up or a Pepsi bottle, you paid for the bottle, and when you returned the bottle, you got your money back on the bottle. That's what should be done for e-waste too, right?
Absolutely. I think
for all kinds of waste.
All kind of material per se.
Right.
So if you're looking at a container, like actually when we are buying that bottle of Coca-Cola, we are treating that as something, we own the content of the bottle, not the bottle itself.
That's right.
So we are giving the bottle back to get our deposit back.
Yeah.
So that needs to be implemented. Those days it was like actually we had to physically go somewhere and do that kind of thing. So it is DRS enables that to digitize the entire flow so that it becomes a part of the consumer behavior.
Right. So Recycle has done a pilot in Uttarakhand.
In Kedarnath, all the Char Dhams.
The Char Dhams. So it works like this. Any bottle containing a beverage has a QR code stamped on it. Anything that enters the Char Dham area. And when you dispose of it, you take a picture of the QR code and you get an automatic transfer of the deposit. And they know that that particular bottle, plastic, has gone into the bin. And the bin also takes a photograph. So they know exactly where it's gone.
Yeah, so we had implemented it in Kedarnath first. So we won a Digital India Award for that.
Right.
I mean, by Madam President. Then we had implemented it across Char Dham. Now we have implemented in Bhutan too.
In Bhutan?
And, yeah, so in a place called Gelepu Mindfulness City. We are also implementing, working with the Goa government to implement it in Goa.
Great. Okay, we just have just some time for maybe a last comment. I'd ask each one of you, if there's one change that you'd like to see. The reason I'm saying change is because in the field that they're working in, that's going to be how we're all going to be thinking in the future. We're all going to be thinking about how we consume, because mining the earth for fresh minerals is not going to be working out for a long time. We'll have to mine what we have, what we use, reuse and recycle what we already have. So awareness is the key part of it. Like he says, there's a nice route, a supply chain to how things come and reach your houses. You know how to buy things, and it's all, from the store. And there's a very convenient route. But that reverse route doesn't exist, and we need to build it. So what would be one big change that you would like to see in the management of e-waste? I'll go with Pardeep first.
So I think we are still not thinking about how the inroads has to be made on the consumer aspect. So just giving a picture, we have started thinking and we have implemented a site called SellSmart, where a normal consumer can go fetch a value. SellSmart. So it's basically a portal where you can go sell your old gadgets and get a value for it. A value could be a cash incentive, or it could be a voucher of an OEM associated with us, where you can be given a discount on a new purchase. So I think such kind of models would help you out on the reverse logistics, and would also initiate an awareness that these are products which can be utilized in urban mining rather than sticking to the normal mining process.
So incentivize in that sense.
Yeah.
Okay. What about you, Ravi?
Yeah, the same thing, incentivize. So right now, who is out of our ecosystem is the producer. So the producer actually generates all these things, but they just consider this as a regulatory...
The producer of a device.
Of a device, yeah. Of an appliance.
Appliance.
Yeah. So they just think right now it's just a government regulation that they have to do the EPR compliance.
They have to meet so many targets of bringing it back.
Yeah, but they're not really bothered how it is done. And second thing is, they're not... they don't show any inclination of actually how they can use this urban mined metals and plastics that we are talking about.
How it would benefit them.
Yeah, it's does not benefit, because they need to make some design changes, because the recycled metal, recycled plastic doesn't actually has the same properties of your virgin metals and plastics. So the government has to kind of pitch in here and come up with some kind of incentive program where the producers think it has been their benefit to adopt the recycled metals and plastics. No matter how much ever we gonna actually recycle and keep it, and if it is not going directly to the OEM, and if it's going to the refinery, it's nothing but a trading.
Yeah, because again, you're going through the same process.
So we need to find a way to reach to the producer.
Yeah, you want to say something?
Yeah. So if we read the EPR regulation, the government has already implemented that by 27, the percentage of recycled metals have to be incorporated in the manufacturing supply chain. May it be for batteries, may it be for electronic waste. So those are the scenarios which, implemented properly, will create a circular economy and help out on those aspects. So I think so those are the initiatives which are on the right direction and would help this industry and to take care of this waste.
Yeah. What about you, Vikram? We've got half a minute.
Yeah, actually, both of them were talking about it's primarily the policy. I've seen this already happening with plastics. So if you look at prior to extended producer responsibility, what the waste pickers used to collect used to be like bottles and other things which are recyclable plastics. When it comes to flexibles, which is our lace chips, like chips packets and other things, they're just left there. With EPR coming in, those are collected because there's a main target which the brands had to meet in terms of collecting that waste. So regulation plays a huge role in terms of how the material is collected back also. Same thing needs to happen with actually the mandates. We already have this battery mandates in terms of how much of recycled material needs to be used as part of the battery manufactured. Same thing should happen with e-waste. So as it is mandated, that is a lever on the top, which is at a producer level, and there needs to be a lever at the consumer level in terms of deposits refund, so that you know that you're conscious that there is this money which is going to come up,
and you know where to go and
deposit it back, take back policies.
The problem a lot of people face is they don't know how to dispose of.
Exactly.
All right, our time's up. Thank you all very much. Great conversation, I think. Hope we've learned a lot.